All right, good afternoon, everyone, and welcome to the Autonomy and Advanced Autonomous Technology panel session. My name is Rosemary Shapdalen, and I'm the president of L3Harris Maritime Sector. I'm honored to be here to introduce this exciting topic, and I thought I would start with something that occurred over 6 years ago, where the leaders of the World Economic Forum announced that we have entered into the fourth industrial revolution, and that is characterized by the convergence of digital, biological, and physical innovations. This new era is taking automation to the next level by enhancing it with artificial intelligence and machine learning algorithms, as well as data fusion to improve and accelerate the decision-making process. When looking at applications in defense, we see how technology is profoundly impacting national and international security, affecting both the probability and the nature of conflicts, where modern conflicts are increasingly hybrid in nature, combining traditional battlefield techniques with asymmetric strategies and adding technologies such as autonomous weapons. And this new threat environment is driving us to accelerate our innovation in the area of autonomous operations to ensure we create the advantage posture in these conflicts. When preparing my remarks today, I was thinking of a simple acronym that could capture the tenets of autonomy, and I came up with ERA, E-R-A, endurance, reliability, and accuracy, which leads to the challenge we face in unmanned operations, and that is at what point we not only gain acceptance of autonomy, but give empowerment to the autonomous system. And that comes down to trust and confidence. Trust in the vehicle endurance, trust in the reliability of the systems, and trust in the accuracy of not only the sensors on the platform, but that the data provided is uncompromised. So it includes trust in the robustness of cyber resiliency. The good news, as you heard from the CNO this morning, is that both industry and our maritime customers today are conducting operational scenarios with unmanned vehicles, such as manned-unmanned teaming, torpedo tube launch and recovery, as well as experiments with payloads to see how they can best be utilized and effective in this capacity. The future state of autonomous operations has the potential to deliver mission and situational awareness that enhances survivability and lethality, as well as provides real-time decision-making. And this capability will be enabled by merging AI/ML to autonomous systems, having high quality and accurate sensors and effectors, as well as cyber resiliency, and having self-monitoring and real-time healing of HM&E. L3Harris is proud to be a partner with our maritime customers and industry as a trusted disruptor to bring these advanced autonomous undersea and surface technologies to the fleet. So without further delay, I'm pleased to turn this topic over to our esteemed panel to learn more about the progress we have made and what the future holds in this exciting domain.
All right, thank you, Rosemary, for those words. Endurance, reliability, and accuracy. I may have to borrow that with your permission, so thank you for that. Good afternoon to everyone. Thank you for being here for our panel today. Especially thank you to the Navy League, obviously, for this event and for the panel today. Very exciting topic. I have really what I'm going to call my co-panelists today. It's the three of us. So myself and then Mr. Larry Ryder and Mr. Jason Potter, whom I'll introduce. Privileged to have both Larry and Jason here today. I think as a panel, you're going to get a very well-rounded discussion, I believe, on the topic of autonomy with obviously me representing the Department of the Navy view, but an industry and trade perspective from Larry and a congressional perspective from Jason. It's going to be a great panel, so thank you for being here. My plan today, a little bit different because it's just our small fireside chat here. I'm going to introduce Larry and Jason, and then after that, each of us in turn will make initial remarks, and we'll have some discussion and Q&A. So, all right. So first, very happy to introduce Larry. Larry is actually here in his capacity as the vice chair of the Association for Uncrewed Vehicle Systems International Maritime Advocacy Committee, or AUVSI MAC, for those who are involved with that. So Larry is the vice chair of AUVSI MAC. He is also the chair of the Amphibious Requirements Committee of the NDIA Expeditionary Warfare Committee. So in those capacities, particularly for AUVSI, as I mentioned, he's representing the industry and trade view today. Also in Larry's day job, he's vice president of business development and external affairs for Austal. Larry's a retired Marine with over 21 years of service. Also has extensive experience with shipbuilding programs, including on the government side as well, was the first director of the Marine Corps High-Speed Vessel Program Office, where he helped develop the Expeditionary Fast Transport Program, and also served as the deputy program manager for the Joint High-Speed Vessel Program in PO ships. In addition to his work at Austal now, Larry also spent time with General Dynamics working Littoral Combat Ship and EPF. So a lifetime of career in shipbuilding following, he's also a graduate of University of Pennsylvania and Naval Postgraduate School. So Larry is just an awesome member to have on the panel. So thank you for being here today, Larry.
First time I've been called awesome in a long time, Casey. Thank you.
Well, I'll see if I can raise you to an exceptional by the end. So thanks, Larry. All right. Our third co-panelist here today is Mr. Jason Potter. Jason is a professional staff member on the Senate Armed Services Committee, has been in that position since 2015. His current portfolio includes oversight of Department of Defense acquisition policy, Navy programs, and other Navy and maritime matters. And I have to say that in his capacity, obviously, we work together closely throughout the year on multiple occasions, as do Larry and I, actually. So prior to joining the committee, Jason served in civilian positions on the Navy staff OpNav, including as a force structure analyst in OpNav N00X, special assistant to the CNO in N00Z, and section head OpNav N80. Jason served on active duty as a naval officer for 6 years, including on the USS Cape St. George and the USS Rushmore, and continues to serve in the U.S. Navy Reserve. He has a BS from the United States Naval Academy, an MBA from Naval Postgraduate School, and an MA in government from the University of Maryland. He's just an excellent background here, and happy to have him. And I think we wanted to stress that Jason is here today as an experienced Hill staffer, and his views may not necessarily reflect those of the committee. But it's great to have this perspective. Again, I think it's going to be wonderful with these two gentlemen on the panel, so thank you. All right, so first, some remarks for me to set the stage a little bit. So autonomy, I will say, is not a new topic for the Department of the Navy. For some time, particularly in the unmanned systems world, we've been testing and fielding systems with varying degrees of autonomy. Unmanned aviation systems are, of course, already long fielded and in operation, with more advanced systems in development. Unmanned underwater vehicles are in extensive use in the oceanography mission and are also already fielded and in our expeditionary mine countermeasure units and other areas. But there can be no doubt we are moving towards more complex and capable autonomy in our new planned USV and UUV systems, particularly large USV, medium USV, extra large UUV, and submarine capable UUVs, as well as the Marine Corps' plans for the long-range USV. Data and autonomy is but one of the key enablers for these systems described in our unmanned campaign framework, and autonomy is not the only key technology or characteristic of unmanned systems, with others including reliability, integration into networks and combat systems, vehicle monitoring and control, cybersecurity, the use of artificial intelligence, which is actually a much broader topic than autonomy, and others. But autonomy is certainly one of the most technically complex and important efforts in the fielding of unmanned systems. In PEO Unmanned and Small Combatants efforts, my command, it is one of the key systems engineering pillars for LUSVs and MUSVs. We are conducting prototyping with our Overlord and Sea Hunter USVs. This prototyping is testing and advancing both mission and navigational autonomy. Our prototypes employ autonomy systems developed by several different companies to allow us to experiment with different systems. We have gotten exceptional feedback from SurfDevron 1, the operational unit as a result of our prototype testing. For UUVs, again, of course, we have several systems already fielded with basic autonomy, and capability will only improve from here. Initial capability is focused on mission plan execution, navigation, and obstacle or contact avoidance. This level is already supporting successful operations. Advanced algorithms, better sensors, edge computing, and artificial intelligence and machine learning will improve autonomous capability to enable more and more complex behaviors and missions. Technical capability of autonomy is one aspect, albeit an important one. AUVSI is also focused on how we will acquire autonomy. One key principle we want to employ is open standards and interfaces. Within the technical baseline of the vehicles themselves, we have worked with industry and others to develop the Unmanned Maritime Autonomy Architecture, or UMA. This system of common interfaces and services will enable us to solve once and scale, as the Unmanned Campaign Framework guides. We can avoid platforms with distinct and not common systems, avoid vendor lock, and can employ elements developed by different companies or even from S&T, academia, and others. Beyond the platform, we are developing an organizational and contract structure for how we will buy and manage autonomy, including through the use of an autonomy baseline manager for the government and platform autonomy architects. We plan to use our prototype vessels to actually prototype our acquisition approach in addition to the technology. Even within the Navy, we are practicing how we will acquire ships with autonomy. The conversion of EPF 13 to include autonomy capability is a great example, where PO Ships is managing the ship effort, but AUVSI, specifically our Unmanned Maritime Systems Program Office, PMS 406, is acting as a PARM, a participating manager, providing the specifications and test plans for the autonomy system itself. This is sets and reps for how we will do this when we build autonomous platforms at scale. Another interesting aspect of autonomy acquisition is the broad industrial base we are working with. Shipbuilders, traditional combat system suppliers, companies specializing in autonomy and automation, design agents, and others, both large and small businesses. Beyond just AUVSI, there are cross-Department of the Navy aspects of fielding autonomy. In January of this year, ASN RDA, Mr. J. Stephanie, designated AUVSI as the existing PEO to act as the acquisition executive agent for autonomy, as it was a requirement of the FY21 Authorization Act. This is a role which I think will be of significant value as a facilitator for coordination and cooperation in DON autonomy efforts. We are just ramping up these efforts, but I consider potential focus areas to include a general strategy and roadmap for DON autonomy efforts, a focus on the application of autonomy to both manned and unmanned platforms and systems, a coordination of priorities, including in both S&T and acquisition, an examination of specific areas of interest in autonomy, such as definitions and standards, policies, processes, test and evaluation, integration and interoperability, input to program requirements and acquisition, roles and responsibilities, and others. A final topic I would like to discuss is that of trust in autonomy, and Rosemary had some excellent comments here. It's a topic I think about a lot because it's a challenge not as easy to solve as the technical and acquisition implementation. It involves complex aspects of law, policy, and Navy culture, and the acceptance of change. Within acquisition, we have discussions on plans on what technical authority means with respect to autonomy and AI. How do we certify autonomy in the sense that we already certify weapon systems? And with the mention of weapon systems, I will stress, of course, DoD policy of human in the loop for engagement decisions. Also, how do we best assess designs and test capabilities in navigation and seamanship to achieve certification of autonomous systems? Within NAVSEA and the PEO, we can figure this out. But more broadly, what is the best way to gain fleet acceptance? The certifications are important, but prototyping and experimentation and fleet sets and reps are key too, which is why I am such a big fan of concepts such as Fifth Fleet's Task Force 59. But this question of trust will entail such fundamentals as how do we consider command responsibility when it comes to unmanned systems? And then also, what defines good enough to field in terms of autonomy? Current USV systems focus on avoiding collision. More complex behaviors aided by sensing and by AI ML will come, but what is good enough to field, factoring in the level of remote monitoring and control? The broader maritime world has not even answered this question fully, with IMO looking at autonomous systems and the prevention of collision at sea, and maritime classification societies establishing initial class rules and standards in these areas. All this, I believe, is a truly fascinating and critical topic as our Navy transforms to what CNO calls in his navigation plan, the hybrid fleet, manned and unmanned. And I look forward to discussing it further with you today. But first, we'll get our excellent perspectives from Larry and Jason. So next, over to Larry for his comments on his perspective as Vice Chair in the AUVSI Maritime Advocacy Committee. Thank you. Larry.
Thanks, Casey. And thanks, Rosemary, for the introduction and for L3 sponsoring the panel here. As you can see with the packed room, it's one that's of interest to a lot of folks. I want to speak a little bit about what AUVSI does and what our role is, and a little bit about the successes we've had, and then maybe some of the challenges, especially as Casey hit on from the industry perspective. One of those is how the government goes about acquiring the different platforms and systems. And with the government, we're working through that ourselves on the industry side. It's a little different than what we're used to, I think, in a lot of the more traditional programs, or previous programs, I guess is a better way to say it. So AUVSI, the Maritime Advisory Committee, we represent about, or we have about 25 members, firms from across defense industry, commercial industry, USVs, UUVs. So we represent a pretty good swath. We have some real smart folks in that group, and I think I missed the last meeting, so I got voted to come here instead of the smart folks, so I apologize for that. But we do represent a pretty diverse base, some very small startup firms with some cutting-edge technology, some more traditional firms, like what I represent, and some of the larger companies. We range large to small, all domains, commercial to defense. And we have members that are focused on the software, we have members that are focused on data as a service, and we have members focused on the platforms. So it's a pretty good melting pot trying to figure out how we can best support the government's acquisition plans. One of the things we've worked hard at over the last few years as a committee is to increase our collaboration and work to support where the government's going, but also to promote industry. It's not one or the other, but we try to row in the same direction for the most part. Doesn't always work, but we do have that general aiming point of fielding capability to the warfighter. We've had a great exchange with Admiral Moten and his team, Captain Small, and we're looking forward to doing the same thing with Captain Searles as he comes on board. We worked with OSD, we've worked with the Department of the Navy. We've had great exchanges with the Unmanned Task Force. We're running some acquisition workshops. We run a trade show, Exponential, that has a defense element to it that this year is going to have a sidebar with a workshop focused on acquisitions. So there's a lot going on in that advocacy space. The other piece is we've been able to get up on the Hill and had some I think some very positive meetings and productive meetings as we've tried to explain industry's perspective on some of the concerns Congress has had, and try to work through what they're looking for and where we are as an industry. There are some successes out there, as Casey mentioned. A lot of this stuff, good technical term there, is already there. There's a lot of development to go, but if you look at where Leidos has gotten with Sea Hunter, where the Overlord vessels are with the two teams that have been out operating now, they're both out on the West Coast. On the commercial side, Kongsberg and the Yara Birkeland, is getting ready to start operations. Casey mentioned Task Force 59, several companies out there. Sail drone with a more commercial technology that's crossing over. What's being worked on with EPF 13 to have a very large in-production platform modified to operate as an autonomous platform. Lionfish, the Ingalls Remus 300, DARPA programs with NOMARS, Sea-Train, Manta Ray. There's just a whole host of programs that are moving ahead, a lot of successes, and some learning along the way with things that didn't quite go as planned that we're learning from. How we acquire, I think, is a great topic that Admiral Moten mentioned. And it really bleeds over into requirements. On the platform side, are we building unmanned systems designed from the keel up to be unmanned, where DARPA's NOMARS program is headed, or are they optionally manned, where you have a lot of the requirements of a manned system with the ability to go unmanned? Different concept, different perspective on how you approach the design effort. There's the platform you're building, there's the autonomy package, both the mission autonomy, the nav autonomy, and then there's a sensor suite. Again, industry, I think our challenge is trying to pair up and put the best package together while the government's trying to figure out what the requirements are for 3 or 4 different sets of capabilities that are going to be bundled up into a package. One of the things I think we've talked about a lot on the industry side with the Navy is we're moving ahead in an R&D environment with fixed price contracts, which has been a challenge, I think, for several of us on the industry side, especially a multi-ship fixed price contract for something that really isn't defined. And then there's whether we're in the one-off stage or whether we can ramp up into serial production. Those are things that I know Admiral Moten's folks are working on, and we are as well. And then finally, some of the key challenges: reliability, the trust factor that both Casey and Rosemary mentioned are big. And then the transition plan. How do we get from these various R&D programs we're working now into sustained production so we can get numbers out to the fleet and really start testing the assets out in an operational environment? Take what's happened in CTF 59 and what's happening to a lesser extent out in the West Coast and ramp that up to where the fleet really gets a chance to operate with the platforms. And I guess the last thing that I'll mention before I give up my time here and let Jason speak is the question of how this fits into the fleet architecture and where the balance between manned and unmanned system is going to be, and what is industry really ramping up for? Is this going to be 50 platforms, a couple hundred platforms, similar to the issues we have on the manned side? What's the long-range plan look for? How do we capitalize? How does industry ramp up? The same thing on the unmanned system, getting to that point where we can see a longer range plan than the year-to-year budget so that we can adjust accordingly. So with that, I appreciate your time. Jason?
Yeah,
Okay, thanks, Larry. Jason?
Thanks. Yeah, let me echo what the Admiral and Larry said. Thanks for the invitation. It's great to be here. I also agree with Rosemary on ERA, and I think some of the things I'm about to talk about will probably resonate there. Not really look forward to your questions, so I'll try to be brief. From where I sit, I think there's kind of 6 key questions when you're thinking about the business case for autonomous systems and kind of more broadly, lots of things. And I think it's an exciting time. It's kind of commercial autonomy and solutions are coming at us at a rate that we haven't seen on a lot of other sort of commercial items since some of the acquisition rules have changed. So there's a lot of new players, a lot of non-traditional players, a lot of energy. And so I think it's really important to understand the business case for any given approach here. So my first point would be, what's the problem you're trying to solve? Is this to do more anti-submarine warfare, more mine countermeasures, to do more intelligence collection? Specifically, what is it that's sort of the value to the government or that the government's after asking industry to do? Number 2 is, what's the concept to solve it? Is it an unmanned surface vessel with a payload on it? Is it an unmanned underwater vehicle with a sonar on it? Is it an unmanned surface vessel towing a sonar? Is it an unmanned surface vessel with missiles? So work through the concept and kind of the interconnections, or is it sort of fully autonomous, collecting data and the environment around it, making sense of it, and sort of on its own. But the concept's important, and the way it fits in operationally is important. Number 3, what are the key performance, reliability, and supportability factors to make that concept real? So a lot of times we focus on the potential and the performance that we're seeking, but right there, if it doesn't have the reliability or the supportability within the existing DoD, we've got to work through that. Number 4, what are the key technical detail specifications to get through those factors? So say a reliability factors, it needs to be at sea for 30 days. Let's talk about, has that been done before for a vessel this size? If so, how? Is that the way you plan to do it for the department? Performance, is it demonstrated? So some of this is sort of basic technology maturation, but the details are important because that then informs what I would think is number 5, which is the systems engineering approach to close the gap from where you are with your solution to what the government needs. And I think about it on a spectrum from science to engineering to experimentation. Where science is, it's a technology that's key to what you want to do that doesn't yet exist, and that's what you're working on. So maybe it's a battery, maybe it's an algorithm. There's just something that's not quite there yet. Engineering is it exists, but it doesn't exist in the military application form that it needs to be, form, fit, function. And then experimentation is you've got the form, fit, and function, but you need to adapt it, from kind of basically where it is to fine-tune it for what the department needs. So I think a reality check on where the technology is on that spectrum will inform what I'd say is the 6th point, which is the right acquisition approach. And so once you've worked through the first steps, I think you have a pretty good handle on the technology development that's still to go, the data rights that you need to retain, the data rights that the government needs to have, the interfaces that you need to plug into, the interfaces the government needs to give you. Integration, are you in a lead system integrator construct? Are you standalone? Kind of how do you fit? Subsystem and component prototyping. So is there something inside that's critical to the mission that we don't fully understand that needs to be understood for its own sake? So a large diesel engine on an unmanned surface vessel that needs to run for 30 days might be an example there. Software, legal considerations, like the Admiral mentioned, sustainment. And so once you nug your way through that stuff, then you're at a point to talk about, I think, contracting. And so there's a lot of discussion about other transaction authority, FAR-based, non-FAR-based contracting. All that stuff's important, great tools, but you got to understand what you're trying to do with it and which problem you're solving within that acquisition strategy. Because on a spectrum, there's obviously, as you know, contractor-owned, contractor-operated. They want to provide some output to the government as a service, to government-owned, government-operated, where you're just helping the government run its system. And so in there, the contracting, there's a big difference, I think. So just sort of big picture, autonomy, U.S. unmanned vessels. I think we could have a discussion about internal to the vessel and the machinery control and ship control, and then external to the vessel in the world around it, and then the interplay between it. And so there's a lot to unpack there, clearly. And then the last thing is just sort of the rigor. So sometimes folks get frustrated when questions like along these lines are asked, and I'd say there's an opportunity cost in time and money for getting it wrong. We've lived it on the remote multi-mission vehicle that was canceled in 2016. There's other, manned programs that we've had challenges with that have set us back in terms of fielding and numbers. And so if we have a false start and we sort of get our energy behind it, but we don't have a solid business case, we're really just setting ourselves back until we get on a better footing. So the rigor up front, I think, makes a difference. And I also think it is the fastest way to really getting the combatant commander with the capability they need is working through a process that they can actually then have confidence in and push out forward. And rather than slowing you down, I think it's the quicker we answer the 6 questions, the quicker we can get started, and the quicker it's going to be useful. And then last point is, my boss, Senator Inhofe, has said, you know, as bad as it may seem now and as much of a race as we're in, that if we're hasty, we could fall further behind. And so we need to be eyes wide open that this is not a status quo is the worst it can get. So we've got to put the rigor in to get it done right. Thanks.
Okay, thank you. Thank you, Jason. Thank you, Larry. All right. I think now we'd be pleased to take questions if there are.
All right, cool. How's it going, Jason Knutson? I've heard the Navy putting forward a strategy of like diversification of several different platforms. And it seems like the Navy's really trying to do several different things and get a response. At the same time, I heard a budgetary process that was very systematic, talking about maturing it, right? I'm wondering where there's room for a third alternative, which is sort of an agile process, where we try things that may not be completely de-risked in a way to learn and iterate. And so I'm wondering where we get somewhere in the middle, where there is a risk reduction measures that can be done through experimentation and rapid iteration versus having to prove out the entire capability prior to doing it.
Okay, yeah, I mean, I'll take a first crack at that, right? So I think we're trying to enable some of that, right? The traditional complaint, if you will, may be, right, that we're too platform centric and not enough on capabilities enabling centric, right? If you read our unmanned campaign framework, I mean, it's really almost the principal thing that talks about is to get away from that perspective, right? We do have several platforms going. You know, I view that as a little bit because we're really in experimentation stage and a prototyping stage. I mean, these are all based off of initial early requirements, right? And we're trying to flesh that out to answer one of the things that you said, right? But I definitely perceive like us being able to try and move to do things like agile processes in the autonomy software itself, right? You know, it's a balance between platforms and initial integrators and get something fielded that we can get out there and test properly, but also set up the open interfaces. Another thing I didn't mention is our rail, which is going to be our basically our autonomy, you know, software integration lab to try and be able to do things agilely when we get to that point in terms of increasing capability. So I don't think we're at all opposed to what you're saying. I think we're trying to enable that with our open standards. I'd probably would be the first to admit that we could do better there. And I'd be interested in hearing any other comments from either of my two panelists on that topic. Jason.
Yeah, I mean, I think agile software development is important, and kind of we're too far removed sometimes from the action where the customer and the Navy at that level of detail knows what they need the next software build to do for them, and then they need to work with performers, you know, in working through that. I think, you know, the ARCI model on submarines comes to mind, and just the technology refresh every couple of years, software and hardware, has served us very well. But I take your point, and I think it needs to live though inside of a process where there is sort of a marker for where we're trying to go. This autonomous software development, what is sort of measurable the next thing? And then we get that and then put out the call with enough detail for what you need industry to do for you to go to the next. But I'm not close enough to the action. Something like that makes sense to me.
Yeah. Any
No,
additional
I think like you said at the beginning, the Navy is going after a lot at the same time. I think, you know, I think I mentioned earlier, part of the challenge is do we focus on the platform? There's a developmental effort for the platform that this software is going to reside in. There's the software itself, and there's the mission nav system, or the mission autonomy system, the nav system. As Casey mentioned, or I think Jason, internal to the ship, there's the platform itself and the machinery control system. And then there's the sensors and the suites that go on board. I think one of the challenges is when that's all bundled as a request to industry to solve this, you're trying to pick out different stages of development from different customers or different firms to try to put a package together, when maybe we need to focus on, all right, hold something constant. Say, this is what we're going to work on with this effort. We'll work on the platform on a different effort.
Yeah, thanks, Larry. I will just say, in response to something that Jason said about the framework, I definitely agree with that, right? It can't be like take the autonomy software itself and the avoidance of collision, right? Again, as I kind of said in my opening remarks, it's in the beginning right now, it's pretty basic. It's don't hit anything, right? We're trying to get several different versions out there, see what we like, see what we don't, get that minimum capability, and then we can improve agilely. But it can't just be, just sort of an undisciplined process, right? There should be steps in the complex behaviors of autonomy, right? So we have to lay this framework on how we need to grow the capability and then pull agile on top of it, which sounds easier said than done, but it's a great question. Thank you.
Yeah, so just one quick clarification. I wasn't talking about Agile in software development only. Agile is a broad manufacturing methodology. I think if you lean or quality management too early, that you're going to kill the innovation that you're going after. But thank you very much for all of your responses.
Yeah, understood. Thank you. Okay.
Kind of a little bit of a follow-up on agility. So I heard, Jason, as you were speaking, kind of a balancing act, if you will, leaning too far forward, right, and possibly doing harm or holding back. And I'm curious as to how Congress goes through that. Are we too far forward, or are we holding back too much? And when we talk about agility and experimentation, the hard part sometimes is actually finding the funding to really get after what we need to go get after. And is there discussion within Congress on how to structure experimentation so we are really learning faster and applying what we're learning to actually building and getting out there, both in platform and also in enabling technologies?
Thanks. Yeah, I'd just say, and I'm not obviously speaking for all of Congress, or really anybody but myself, but I think in general the approach is to look at every program, every initiative on its own merits, and does it make sense, kind of what they're trying to do, the stage things are at, look at kind of the subsystems and the components, and that is this kind of a good use of money, recognizing there's risk associated with everything, and we have to push the envelope when it makes sense. So I'd say everything sort of evaluated on its own merits, and then on experimentation, I think there's lots of authorities, lots of energy in Congress, rapid prototyping, OTAs, middle tier acquisition, to basically take off a lot of the burden of requirements, definition, and operational testing. There's just to sort of clear the channel a little. It's on the department to sort of pick and choose how they work through that, and then to sort of explain the business case for why it makes sense to do this with that system, because this is the outcome we're trying to get to. I don't want to eat up the clock, but I think that's kind of my sense for you, is that case by case, everything on its merits. There's lots of authorities out there. There's lots of pots of money out there. Lots of DARPA, DIU, SCO, non-Navy entities with money looking to do experimentation. So just keep knocking on doors and making the case. Yeah.
Thank you.
Yeah.
Hi. As you've noticed, there's great advantages to having open standards and open source software. But we've seen in the World Wide Web world that means that our adversaries know what code we're running and can mount massive zero-day attacks. What actions can be taken or should be taken to try to address this issue?
Yeah, it's, I guess so you're asking almost sort of the trade-off between, openness in our systems and standards and interfaces and security, basically.
Yeah.
Is what you're asking, right? I mean, it's a great question. I don't, I would say in our open standards work right now, we're trying to balance, we are still going to enforce all of the rigor of our requirements in terms of cybersecurity and protection and all of those things and our risk management framework process and all of those aspects of cyber, right? The openness that we're trying to focus on is, not necessarily into the great details of every piece of the software, but basically in terms of interface standards, right? So that we can trade components off and on, we can upgrade components, right? We have everybody sort of talking the same interface language, but we're not necessarily having, all of the details of all of the software and everything out there and available. So I'd like to think that that's a good trade-off, right, in terms of setting interfaces, but kind of protecting the rest of it. I would love to hear more feedback on that approach, follow-ups, those kinds of things. But I think we're trying to strike that balance at the best that we can, right? But the alternative, if we weren't, was just to close everything up, I just firmly believe that that's not the right answer. So we've got to strike that balance. Any other comments on? No. If you have an excellent suggestion, I would love to hear it
Okay.
afterwards. Or
Thank you.
Thank you. Thank you.
Hello, I'm a little shorter. Thank you, everybody, for your presentation. As far as working with industry, I just wanted to put this out there. There's a lot of small businesses, and there are a lot of us that have been around for generations. I am third generation at my family's business. We've been involved with sonars with the Navy since World War II, and we've had that continuity in our field since World War II. My grandfather actually was on a committee under Admiral Fuhrer in World War II, where he designed over 150 transducers and put them all into production in a 3.5-year period. He took those foundations and started our company. But what's happened over time, although we've always supplied the Navy and we are a prominent supplier today, the way contracts have shifted and with what's going on with AUV, sometimes the Navy and other groups wait for industry to come to them instead of keeping in touch with where are the innovations in industry. So my suggestion is, perhaps with your partners that you already have, keep a better relationship in terms of what else are they doing, where else could they go? Because oftentimes things are put out there with what the needs are in a way that's structured so that there's all these parameters, but if it was put out to industry to come out with a solution, perhaps you'd meet your target a little bit faster in a period of time. You're talking about steps and meeting goals, and in a time where you don't have a lot of time to waste, industry can often help with that. So thank you.
Yeah, thank you. Larry, any initial response to that? Or?
No, I fully understand where you're coming from. And we come across, small companies that have great ideas that just don't have a way to plug into, the bigger process. I think, speaking for AUVSI, that's one of the things we've tried to do is provide a venue where, we have the access to meet with, Congress and Jason and his folks and Admiral Moten to try to bring that technology forward, because that's one of the things we're advocating for. Is there is a lot of technology that's more mature than people think, and companies like you are the people that have it. So from an AUVSI answer, I think that's kind of part of it is our mission, is to try to bring those small businesses in. As far as the broader question of plugging into DoD at large, don't have a good answer for that one.
Yeah, I'd be interested to get your contact information, because in the submarine world in particular, PMS 397 has really led the way on some innovations. And sort of being led by the companies in terms of the realm of the possible, in terms of materials and other things. And so, particularly because you're in submarine community, I think they may just be overlooking the opportunity. So
Okay.
that goes for anybody else. Feel free to reach out. We're here to help.
Yeah, it's a great question. It's like the second one in a row that I'm saying I wish I knew a better answer to it. So I'm not sure. I'm going to lose my qualification as a panelist. But yeah, it's a great question, right? And the Valley of Death, et cetera, it's a significant interest to me. You know, I do see a lot of interesting things happening in our PEO, not necessarily in the unmanned world, as we, you know, are trying to use smaller companies. We're doing OTAs for technology introduction that's then feeding other contracts, and we're providing those solutions to our primes. So there are things happening within my own PEO and others that I think are trying to get at that, but I definitely think that we could do a lot better. And I know that's another one I'd be interested in feedback. So thank you.
Admiral, gentlemen, good afternoon. Autonomy is in its early state yet. Back in 2020, PEO USC released solicitation asking for industry solutions to how to make autonomous vehicles respond as a human would. That was 2020. Several of us got contracts to investigate that. We're finishing up now. We've been broadly successful in demonstrating sensor degradation detection technology at the Navy FST booth 537 tomorrow. But we've been told that the Navy is not yet ready for our solutions, and UMAA is not mature yet. Rail is not yet up and running. So my question is, now that we've done what we were asked to solve these problems, where do we proceed from here?
Yeah, I'm not, and maybe I missed the very first part. I'm not completely familiar with what your effort was channeled through. I could get some specifics and I'd be interested. My initial reaction was to solve the problem of reacting how a human would. Well, if you have 100 humans, you're going to have 100 different reactions to how a human is going to react, right? So, but I'm interested in that topic. You know, through the job, I've learned enough probably just to be dangerous in public on you know, AI and machine learning, and I'm learning more every day. And so the problem is of great interest to me. I don't know specifically the circumstances you're talking about how you're kind of at a standstill there, maybe with getting your information considered. And I'd be glad to talk to you some more on that. But it probably ties into the last question, right? Which is
It does. Yes.
So yeah, thank you.
Thank you.
Hi, I'm Jess Rico with Breaking Defense. So one of the flashpoints in autonomy between Congress and the Navy has been developing systems resilient enough to sail without human intervention for 30 days. So I'm just wondering, can each of you give your perspective, the Navy's perspective on how that's going, and from the congressional view, is the progress convincing or not?
Sure, yeah. And I realized I couldn't see the timer, so this is probably the last question. People in the back are probably getting very upset that I'm doing that. So, yeah. So from our perspective, you know, obviously I talked a lot about autonomy, but vessel system reliability is one of the other key tenets. It's one of the pillars of our execution and our systems engineering plan. Right. Obviously, it has been a robust discussion between us and Congress and industry, frankly. Right. You know, the way we are trying to get at it is to do a rigorous look at what we've got to do with both sea-based testing and land-based testing, right? To ensure we had enough land-based testing. Was that a rigorous discussion, possibly involving statute? Yes, but you know, we are on board that our plan needs to take both of them. We are fully committed. That's what we're doing. We have land-based efforts in place, or you know, in planning and execution for both medium and large USV. Right. I think that that's going to be successful. We're trying to do it in an innovative fashion. Right. The one thing that we sometimes worry about with the certification is, are we going to pick, you know, this engine, and that engine is going to be the engine on all of our unmanned platforms. Right. We are trying to do that in a variety of ways, including you know, a program where industry can work to get their systems qualified. We've been working closely with the American Bureau of Shipping on rules that will allow that to happen. So we're trying to do it in a way that balances the need for rigor, but also has multiple industry partners and systems involved, right? And I think we're on board. You know, the 30 days piece, you know, I would say, again, at a top level, there's two ways. I'm oversimplifying. There's two ways to solve that problem. One is an engine that runs 30 days. The other is two engines that run 15 days, right? And so we need to be thoughtful in how we define that and how we prove that we can do that. And I think we had a great discussion with the Hill on that. And I think that you know, we have some ability for us to, I think, have the back and forth with them. So I'm actually happy where we are. It's certainly one of the technological challenges. There are other people working on it as well, the offshore industry. But I'm actually happy with the path that we're on at this point. So, but I guess since I talked about Congress a lot there, I'll let Mr. Potter respond first. But
Yeah, and I'll be very, very brief. The FY21 National Defense Authorization Act included some language on this topic. It was really the 30-day reliability was the threshold objective. That's the threshold requirement for LUSV and MUSV. So essentially, you could interpret it as Congress was sort of holding Navy to their own minimum requirement for endurance. And so then the test program sort of we're not familiar with a way to propel a 2,000 or 3,000 ton warship without a big diesel engine. So whatever we didn't specify it had to be diesel, but whatever it is that's going to move a 2,000 or 3,000 ton ship, we need to understand that propulsion system because that's new. And before we build the ship, and there were 2 per year in the fit-up, so 10 for $3 billion, we want to understand the propulsion because that's a big deal if it doesn't work. And then last year's NDAA was silent. So I think that can be interpreted as we're pretty comfortable. The committees were comfortable with the direction the Navy is headed. So we'll see the details when they come out this year, but that's where we're at.
Thank you.
thank you. All right, I think we're out of time, so I think that'll be the last word. And I just want to thank, again, both of the panelists here for participating. And thank you, everybody, for the great questions and listening. So,
Thank you.